Last time, just a quick review. We talked, not too quick, it's gonna take a little while. Talked about how to insert a new record and some of the gyrations that we had to go through to make that happen. Primary reason we had the gyrations is I wanted to reuse this form. Inserting a new record is filling out this stuff. Updating an existing record is filling out this stuff. Same validation, same form layout. Many books that I've read use two different forms, one for inserting a new record and one for editing an existing record. It's too much overlap for me. So there's a little bit of finagling that we have to do in the code to keep track of, is it an existing one or is it a new record, but it allows us to save a lot of redundancy. So the first thing we needed to do, and it wasn't really the first thing, but we needed to code button new. In button new, we needed a flag to designate that we're inserting a new record, because while we're inserting, if there's nothing in our brand new record, display record, get record can really choke on that. So this flag designates that we're inserting a new record. What I really need to check is, when did we turn that off? Probably on save, but we should, well, there it is right there, so we should check. Inserting new record equals false. Oh, good, we did it. So in here we said, yes, we're inserting a new record, and then we created, instantiated a brand new pizza order, which gave us today's date, one pizza, no size, no cheese sticks, initialized everything to blank, and then we displayed it. When you display an empty record, you get a nice, beautiful empty form that you can fill in, so that worked well. And then we set focus. When the save time came around, though, then we had to take a look at, are we inserting, there's that flag, are we inserting a new record or are we saving an existing record? Because as you know now, it takes two different SQL commands to do that. One is an insert command into the database. I'm sorry, not yet, that's in the business class. Here, if it's a new record, we have to add it to the grid to keep the grid in sync with our database. If we're updating a record, we have to update the grid. So it's two different sets of commands. So that's another place that the inserting new record fits. So that's how the GUI deals with that stuff. The business class also needed to add its own code in save. When we save, we have to be able to distinguish whether we're inserting a new order or whether we're updating an existing order. Two different commands, two different queries in the database. The order of the fields for us, luckily, is pretty much the same, so you can just highlight these, because remember, these were there from part 3 when we did the save. You can highlight those, paste them in here, and it's never failed me. Just don't grab that last one because we don't have an order ID yet. So we created this query, so now let's jump to the XSD real quick. Inside the XSD, we created the insert order query. And then after we're done saving, that record is new in the database. But what we now have that we didn't have before is an ID number for it. Because as soon as we save it, then the auto number field gets the new value. So the next thing we need to know is what value was that. So we added another query that basically just says, give me the max order ID. In the class, we said insert it, and then immediately, billionths of a second later, we said, give me the biggest ID number you got, because it's got to be the one I just inserted. But we had to ask the database, what's the biggest ID number you got? Used your max function skills from the SQL class. Brought that out, saved it into the order ID for this record. So this record, when you create new ones, we fill in all the data, then we fill in the ID, because we have to add it first to get the ID. And at this point, we've added it, but it's now in the database. It's no longer a new record. That's why button save turns off that flag. So we discussed a bunch of this stuff here. Reset the flag to false. The GUI needs to clear the form. That was instantiating it. Things get a little more complicated when we save. Yep, figured all that out. Need to modify save record. Yep, did that. There's the max query that we use to get the maximum ID number from the table. Now the GUI save event needs to be updated. Yep, we did that too. Inserted stuff into the grid. So I talked about all that. And then we needed to make some minor font modifications because when we create a new record, there's no ID number. There's nothing to go get. And if we did go get it, it would be the wrong data. So what we did in the form code is in grid select click, we said, if you're not inserting a new record, then go get one. But if we're inserting a new record, then this basically happens when we insert that record into the grid, then the grid changes. But we're inserting a new record, so we want to make sure we don't go through this process of going to getting the existing record because we don't need it and it actually causes problems. Somebody in the other class said, how do you figure this stuff out? Well, first of all, this bang your head against the wall. First, this is about 15 years worth of experience for me. And for the first year or two, programs would crash or programs would not work. And we needed to modify them. So then I modified them. Then I added them to the notes. And they said, well, how would we ever figure? You don't. I've done all this for you because it is such a common process. You're getting into your heads, I hope, the process that you have to go through to create a database access form. I need to be able to do all that CRUD processing. I need to be able to create a new record. That's what we just learned how to do. But when I create a new record, it has to interact with the grid and it has to interact with the database and the business class. But guess what happens when you get to JavaScript? Same stuff. We have to be able to create a new record. We have to be able to insert a record. Be able to read existing records, to throw them on the right-hand side of the screen, to throw them into the grid. We have to update records. We have to delete records. Now that you've seen how to do it and you see some of the ramifications and some of the side effects that you have to watch out for, that stuff that Val got to see yesterday when she came in and watched the systems implementation class show off Lions Camp, I guess 75% of that was validation that they learned in this class. And yes, it's a little different when you're doing it on the web, but not that much. You still want to make sure the values the user enters are in range. Still want to make sure the required values are there. And so I don't think it's necessary for you to figure this stuff out on your own. Imagine that, right? Here's a database, here's a program, here's my notes. I'll lecture, now you go do it. Or now today, your job, kind of like what's going on in systems class, your job today is to figure out how to do this. But there are so many intricate things that happen that it's nearly impossible. It would take a lot of time. And there's no reason I can't give it to you. I told you at the beginning of this class that once the class is over, you should be able to write a pretty professional looking app in C#. And you will be able to. But there's no reason you need to figure it out on your own because a lot of this just happens over and over and over again. That Lions Camp stuff, or the first version of the Lions Camp program, is this with 30 forms. But guess what all the forms do? Validate, save, grid, delete. Same stuff. Over and over and over again. It's just you got to figure out how do I delete in this, not how do I delete, but what are the fields? What validation do I need? And if you've got a nice design, like you should have done an RDD, it'll tell you the limits, it'll tell you what validation, should it be capitalized? And today we'll talk about those logical keys. So no, I don't think you would expect, I would expect you to figure this out in the time frame that we have. Could you have? Yeah, I think so. If I had a programming logic advanced, it's nothing but figure out how to deal with databases stuff. But then what are you paying me for, right? There's the experience. But this process that we're going through and what we're going to go through today to check for duplicate records is something you have to do in every language. And the process is very, very similar. So if it seems a little confusing, how would I ever do it on my own? The answer is you don't. You take my pizza shop order and you go. You take my notes, which is almost a cookbook, right? It's almost a cookbook. Well, you know why it's almost a cookbook? Because I use it whenever I'm developing a new form. I don't memorize this stuff and all the little ramifications, side effect things we got to watch out for. I go to my notes and I follow them down. They've been rearranged a couple of times over 20 years to say this makes more sense to do it in this order. So I don't expect you to start from scratch and do it without my notes open, do it without the pizza shop open. I don't know how you do it on one screen laptops. You find a way, it works, but much better with 3 or 4 monitors so you put each the different things in different corners somewhere. But that's what I hope you'll be able to do. And then next year when I say, make this web form validate, you go, oh yeah, he promised that it would be very similar to what we did in programming logic. And you grab your DVD program, you grab the pizza shop program, and you say, what was the logic? What did I have to do? I turn off the error markers. Okay, now I'm going to do that. Oh, I know how to do that in HTML. And I have to ask an if statement, is the value, the new value, and it's very, very similar. So next year, maybe not me, but somebody else will say, just do it, you know how. And make it work in JavaScript. I hope. Okay, so we changed that, and then there was a little bit of, oh, then we wanted to do, I think we did this. No, we didn't do that. What I want to be able to do is when the user is running this and they say, I'm going to make a new record. Please. Works every time. I want to make a new record. Start nice and fresh. That's good. But sometimes I get in here and they go, oh, no, I'm not ready for a new one. I want to modify, or something happens. Some are smart enough to hit cancel. Others like to delete. And so what I want to do for my users is give them the opportunity, I don't care which one, cancel. We already wrote that code. When we click cancel, what happens? It goes back to the grid, grabs this record, goes out to the database, gets the details for Eve, and plugs them back in again. We did that before. No, we didn't. We did it for update. Yeah, well, and for new, it's exactly the same because we never saved the new record. Eve is still selected over here. And so if we hit cancel, it says go to the grid, get the ID, go get that guy's data, put it in the form, and wipe out whatever's there. I want my user to be able to hit the delete button instead in case that's the first, I'll just delete this new record. Because that's how real people think, right? Just delete this new record. They don't know that it doesn't even exist yet. And for us, that's a problem. Because we have delete written, button delete is here. And this says, if they say yes, then go into the database basically and delete the record. But it doesn't exist. We never created it. We never got that far. So now we got a problem. What do? Relatively simple answer. Put an if statement in here and say, guess what? If we're inserting a new record, actually, if we're not inserting a record, then do this stuff. Else, do something else. What do we want to do? I got 2 if statements here. Let's see, that's the else for, oops, this one. Next time to clean that up. Oh, my brain's dead. How do I clean it up? Edit. Advanced. Format. There we go. Somebody in the other class was saying, when I do that, it doesn't line them up right. You're missing curly brackets. And what that person was doing is creating if statements without them because I didn't need them. Because there's only one line, then they added a new line, and then they needed them, and they never added them, and it didn't line up the way they thought. So the curly brackets are missing. So my advice was, if you're not sure, just put the curly brackets in always. A lot of employers require an if statement. Swift requires you to have curly brackets, even if there's only one line underneath. C# lets you get away with some stuff. But for many people, it's starting to cause trouble because it almost did for me here. So I had a missing curly bracket. All right, we are inserting a new record. I can't delete the record, so what do I really do? I want it to behave just like the cancel button, so I click the cancel button. She figured it out. Way to go. So let's test that. New. Delete. Perfect.
Clever.
Clever. Sort of. Unfortunately, and I noticed this last hour, and I probably wouldn't have. Where's E's name? Uh-oh. I'm glad I wasn't recording that because I really didn't know what was causing that. I didn't know. So I thought about it and it occurred to me. When I said new, and if I change, it comes back. What? Even worse, right? Because sometimes it works and sometimes it doesn't. I hate those. But it was related to new. When I say new, who's selected over here? It's still Eve, right? And what occurred to me is maybe the combo box. What did I do to the combo box when we displayed a brand new record? I just said wipe out the text. I'm pretty sure because this works, the selected index is still set to Eve, to Beaupre. The selected index is still Beaupre because we never changed it. Wiping out the text doesn't change it if you do it programmatically. And so what I tried was this, and it does work. The problem is when I display an empty record. And it's for the customer right here. And there it is, I wiped them out. But by wiping out the text, it just takes the text out, but the selected index is still set to Eve. And so then when I said start over again, it said set the index to Eve, and it said it already is. I don't have to do anything, and it never put his text in there. That's what happens, I'm pretty sure. So it's kind of a little flaky thing. I'm going to add some curly brackets because my philosophy is if I have curly brackets on the else and I need it to be, I should have curly brackets on the if. That's my philosophy. So here, in addition to wiping out the text, I'm going to set the CMB customer dot, and I tried to do selected value equals null. But you can't do that. Because it's connected to the database, there is no matching record for null because we're bound to that binding source. This was perfectly legal last semester because we weren't bound to the database. But I can't do it now because I am bound to the database, but I can set the selected index to that illegal value of -1. And so now when I run my program and I say new, it wipes out the text, but behind the scenes, it's also set the selected index to -1. I have no idea what it did to the selected value. It doesn't matter because now when I cancel or delete, it says, oh, I changed the selected index and it displays its name. I don't know why it occurred to me. It's not an error that I've seen from last year. Maybe I'm coding it differently. But again, somebody in the class said, how did that even pop into your, I don't know. Experience. Isaac?
Changing the selected index by itself won't clear the combo box.
Interesting thought. Let's find out. My gut feel is no. It will not change the text. Okay, so what you're suggesting is maybe I don't need to do this one. Again, because it's bound to the database, I don't think this is going to work. It's going to leave his, if it does, we can leave it, that's fine. But I know that when I start binding combo boxes to databases, often I have to do both. I have to set the index and the text. Let's find out. No, that's good. So far. So now high five the other direction. What happens if I delete? Put them back? Yep. So I could save a line. I know somewhere there's an issue with that, but this isn't it. So when it comes up, we'll fix it then. So good. That's a nice shortcut. Setting the text to the empty string, I got to add that to my evaluation sheet. Setting the text to the empty string isn't good enough. It isn't really right here. We have to set the selected index, so after we do a new and come back, it's okay. So that was a little side effect. And remember, the main reason we were here is because we want to hit delete. If the user hits delete, delete the new record. But we programmers are smart enough to know it doesn't exist. So we click the cancel button instead, and it just refreshes the last person that was on the screen, brings them back. Okay. Today, our mission is to catch duplicate records. All of you, at least in this group, are in the RDD class or have been in the RDD class, and you remember that old crusty logical fields, logical keys thing that made database design, table design so difficult. Primarily because I don't think you had an application, you couldn't see it in an application yet. Now we're going to use it. What we want to be able to do is say that record is already in the database, but I have an auto number field. Whenever I insert records, I get a new number and it's not already in the database, but that doesn't prevent me from putting Nathan in the database twice. Well, it's pizza orders. Can you order multiple pizzas? Yeah, sure you can. So now we have to figure out, all right, if we're looking at this form, what makes a duplicate pizza order? And this is kind of what I was trying to explain to you in the RDD class. What makes a duplicate customer? What makes a duplicate product? What makes a duplicate representative? How do we know? Suggestion, Isaac?
I mean, part of it would just be having the same order date and name, but that doesn't catch everything.
Doesn't catch everything, right? Because, me, I order pizza and I'm trying to lose weight, so I order pizza, but it was so good, I want another one.
And you get different.
And I don't even want the same one. That was so good, I want that same piece of pizza and 20 breadsticks and Coke, right? Because I'm trying to lose weight. But anyways, no, but that makes this very difficult. How do we tell one pizza, Volker's first pizza order from his other, because they're identical orders from the same person on the same day? We have a flaw in our database, and no, I'm not going to fix it. Okay. I need a time, right? Or, when we get toward the end of the class, I'll give you another alternative. What about DVDs? You're doing DVDs, right? How do you tell duplicate DVDs? Probably by the title, but I have 2 copies of Princess Bride in my collection because that's an awesome movie. One's what?
One's Blu-ray.
One's Blu-ray, one's not. What's in your grid? Title. So in his case, and I don't have a big problem with it, I think I even advised him that if you have 2 titles that are Princess Bride, how many are there going to be? 2. One of them's Blu-ray, one of them's not. Click on one, that's not it, must be this one. That's not so hard to find the record that you're looking for. Okay. But when you're checking for duplicates, even though it's not in the grid, you're going to have to check the title and the Blu-ray flag in combination. Isaac, what are you doing? DVDs?
Yeah.
Okay. Just for the recording, for the people doing car maintenance. Whoa. What's the difference between this oil change and that oil change? The vehicle I did it to. Okay, so that's 2. I need the procedure and I need the vehicle. But can I change the oil on my car twice? I hope so. What's the difference? Date. That program has 3, that table has 3 logical keys. The DVD program has 2 logical keys. This one, to simplify the example, is going to have 2 logical keys. No, Volker, you can't have another slice today, come back tomorrow. This is the diet pizza shop where we don't let you order pizza twice in the same day. I'm just limiting my program to make a reasonable example. Otherwise, I either got to add the time or I got to do something to distinguish one of Volker's orders from the other. Isaac?
Just thinking too with like DVD or car maintenance, I mean, technically what if you have the same car, your spouse had the exact same car, and
Yeah.
you decide to get the oil changed for both of them yourself on the same day?
I don't care. Okay? His question is, because it didn't make the recording, what if I get the oil changed in the morning and then my wife says, we're supposed to get the oil changed. She drives it in and gets it changed again in the afternoon. I don't care. One day, good enough, we'll leave the other one out. And we just don't get to go out to eat that night because we spent the money on extra oil change. So that's an issue. again, here, it's not 100% foolproof because if I really want to order 2 slices of pizza on the same day, I can't do it. But remember, this whole thing has been an example of samples. It's not real. When I put a quantity in here, the number of pies, it also affects the number of sodas I get, and that's not. But to make it real just makes it more complex than it needs to be. The point is, you got to find out the logical keys, and poor Val's got to deal with tortoises. Okay? If you need help, ask me. But really the question is, how do you tell one tortoise from another, or one tortoise measurement, or whatever it is from another? My notes will tell you that you probably already thought about it. Because in the grid, how do you tell one beer batch from another? How do you tell one tortoise from another? How do I tell one pizza order from another? Name and date is what I have in my grid. If you put it in your grid, it's probably a pretty good logical key, or close at least. So you already thought about it way back in part 2 when you built the grid. You said, this is what I'm going to use to look up tortoises, beer batches, DVDs, whatever. You probably already thought about it. So that's where I would start. Use what's in the grid as a starting point, but you still need to analyze it. And maybe when you're testing it, you'll go, not enough, need more fields. So those logical keys are part of it. By the way, logical key is a Volcker term. That is not something you'll find in a database design book. If you say it to Jason, he'll go, oh, never heard of it. It's something that I find very important because of the way I build these programs. And no, because of what we have to do to check for duplicate records. We have to know what fields are we going to look at. Do I want to leave that to some beginning programmer? No, I'm going to be a systems analyst. I'm going to mark it in my database design that these programmer are the fields you need to check for logical keys for duplicate records. Your book in the RDD class talked about candidate keys. Okay, close enough, but once the author picked his real keys, he ignored the candidate keys. He ignored their value, I think, in validation. So, my turn, but I think it's very important. And when we get to web-based, Swift-based databases, want to avoid duplicate keys, we got the same problem. What am I going to check? So the grid starts, but your design should have it in there. But that's a big brash assumption, of course, that you have a design. So let's jump ahead. I'm going to jump around here just a little bit, just because it's easier to explain in this order. If you're using this as a cookbook, you'll understand what that previous paragraph was talking about by the time you get around to doing it. First thing I need is some way to know, is this a duplicate record? Who do I got to ask? The table. So the first thing I want to do is come up with some SQL in this table adapter to say, you got a record that looks like this? So how do we do that? We're going to add another query. Holy cow, we're up to 1, 2, 3, 4, 5. Yep, here comes number 6. I'm going to add another query. I'm going to use SQL. And am I updating? No. Deleting? No. Inserting? No. So it's got to be one of these top 2. What am I going to ask? The question I'm going to ask is, how many records do you have that looks like this? Because in SQL, it's tough to return a Boolean. We could do it, but it's easier to do it the way I'm going to show you here. I want to know, how many records do you have for Volcker Gall ordering pizza on this day? How many do I expect? No. How many do I expect if I'm checking for duplicates? None. Yeah. I expect none. If there's one, then guess what? This new one's a duplicate. So all I need is a count. 0 or 1. There better not be 2 or 3. There could be. I'll explain why later. But there should be 0 or there should be 1, typically. So I'm going to create a query that returns a single value. We've already built one of those. My last ID returns a single value. If your query does not return multiple rows and it only returns one number, that's this query right here. Next. Please. Thank you. Oh, cool. Count star, just what I want. How many of these do you have? 0 or 1. This is going to count records for me. Perfect. Now what though? Count all the records? No, no. Count the records where my logical keys already exist. In this table, my logical keys are customer ID equals something. I'll pass you the information later. And the custom or the order date is something. So I'm going to, every time I call this query, I'm going to send it an ID and a date. So you got one of these? When you're doing DVDs, you're going to send in a Blu-ray flag and a title. You got one of these? And every time we call this query, we have to send it that information. Go ahead.
Wouldn't you be asking select where customer name?
Where what?
The customer name.
No, because my order table, this is the orders table, doesn't have a customer name anymore. Remember, we took it out and linked it. I could do a join here, but I really don't need to because I have the ID number. It's in the background of my combo box, right?
Well, that's weird. Why would you ask for it if there's a duplicate ID? Because isn't that possible?
It's not a duplicate ID. It's a duplicate ID and date combination, right? I can have lots of orders today for pizza. I hope so. I hope you come back, just not today, is our rule, right? So it's the two in combination that I'm looking for. There's going to be lots of Blu-rays. There could be multiple Princess Brides, but there should probably only be one Blu-ray version of Princess Bride. By the way, just in case you decide to get mouthy today, I'm recording CN. So now that's in the recording. But today I'm recording in this hour, just so you know. No burping, none of the other stuff you usually do. Okay, so here's my query. This is going to tell me there's either 0 or more records in the database with these logical keys. I expect there to be 0. Because if I'm asking, is this a duplicate, I expect the answer to be no. Next. What do you want to call this? I think I called it duplicates found, which means how many duplicates found, but I don't want to write it that big, so just here's how many duplicates I found. If you got a better name, use it. I don't care. Next, query's good, finish. So now I have a new query in here. So now my data class has the ability to find out how many records there are with these logical keys. After we're done with the data class, where we go next? Business class. Because we've done this how many times? For every one of these queries, we want to delete something. Okay, build a query, write a function in the business class to do it, and then do something in the GUI to make it happen. It's pretty much always the same process. Do the data class, then the business class, and then finally link it somehow into the GUI. This one, as it turns out, never gets linked to the GUI. What I need in here is a data access function, because we're going against the database, that checks, is this a duplicate record? Remember, we're in the business class now. We got a complete pizza order in there, right? With all our properties and members all filled in, here's a pizza order. What we want is a private function, because the GUI is never going to ask this. The GUI doesn't ask. So it's going to be a private function that returns a Boolean. It either is a duplicate or it isn't. And I'll call it isDuplicate record. Done. So what we're basically going to ask in this function, this method, is the current record data already in the database? I could say this method determines if. I think that's okay. It's a complete sentence, right? English majors? Mm-hmm. So is the current record already in the database? What do I mean by the current record? Whatever is stored here in my properties, all this stuff. I think I might have described it a little better in the other class. Are the logical keys already in there? So now, how do I know? Well, I'm going against the database. It means I need one of my trusty dusty TAs here. And that's going to be equal to a new DS order table adapter, and I'm using the big one for orders, not customers. Make sure you get the right one. I've already seen that a couple of times now where people are using the wrong table adapter and they're getting errors going, I've never heard of store name, or I've never heard of customer name. That's because it's in the other table adapter. This one for queries, for customer lookups, order lookups, customer data. That one we're not going to use much. And this is the one that's got the 6 queries in it, the one we use the most. Parentheses. We've done that. Every one of the queries does it, right? Now what? Now I need to execute my duplicate records query, and it's going to send me a value. So temporarily, I'm going to create this count variable, and then I'm going to say the count is equal to the TA duplicates found. But the duplicates found, that query needs 2 pieces, in my case, 2 pieces of information. What are your logical keys? You're doing car maintenance, right? If you listen to the recording, I explain and even tell you what the logical keys are for car maintenance. Okay, duplicates found. I need a customer ID. Okay, customer ID. Then what? Order date. Okay, order date. We did all the hard thinking already when we built the query. Here, we just have to make this guy happy. It's not happy. This is kind of generic, but if I hover over that, notice all the way over to the left, Nathan's going to have to read this. Okay, it says int question mark. It's possible to run a query that returns nothing, right? You've done it probably in the RDD class. You ran a query and you got nothing in the answer set. But this query is a single value query. It always returns a value. We could say, trust me, it's an integer. I promise it will not be null. If it is null, converting it to an integer, we could do that. Somebody discovered, I don't remember who it was, that since that's nullable, what we really want is the value. Just like all the other nullable variables you've got in your program, to suck the number out of there, you use the value. That makes a little more sense to me. I could say default, value or default 0, but there's never going to be that. I know, I wrote the query. It's always going to return a value. Now I have a count. What do I want to know about the count? If the count is greater than 0, it's a duplicate, right? Then return true, else return false. Make sense? Isaac's nodding. Good enough for me. The rest of you don't get it. Talk to him. No, it makes sense. Go out to the database, run this query to find out how many records there are that have this customer ID and this order date. How many are there? Is that number greater than 0? If it is, then we return a value true for is duplicate record because it's already there. These are my logical keys. For my table. Yours are going to be a little different. Again, it's in the recording. So this makes sense, right? Good. Let me show you the shortcut version. Go to the database, find out how many are. Is that number greater than 0? That's either true or false, right? Return it. Done. Don't need any extra variables. Don't need this if statement. And by the way, this if statement, when you gain even more experience, and I'm going to keep talking about it. When you have an if statement that says set it to true when it's true, you don't need the if statement. Because this says return true. If it's false, return false. Well, why don't I just return this? You can. You'll get used to that after a while. You'll write the if statement. If you find yourself saying, if it's true, then do true, else do false, you don't need an if statement. Use a Boolean variable, a Boolean flag. I'm returning a Boolean. Oh, perfect. Take a look at this value that I got out of the database. If it's bigger than 0, return true. If this confuses you, then use the bigger version. That's fine. But at some point with experience, you'll start writing stuff like this, especially in the Swift class. I mean, all the Swift books, all the Swift tutorials, often they've got this big, huge monster equation right in the return statement. Because they can. Okay, what else we need to know? Did all that, did the count star with your logical keys. There's my duplicate record. Just like I just did it. I think in the other class, you wouldn't know because I didn't record it, but for them that are listening to this, I said not equal to 0. It's never going to be negative. How could there be negative rows that have these values? It'll either be 0 or 1. So not equal to 0, greater than 0, all the same. Now I need to back up. And I'm going to run this program and not check for a duplicate yet, but give you kind of where we're heading here. It's almost break time, so I think we'll do this when we come back. If I do a new record, should I do a duplicate check? Yeah, it's new. Why wouldn't I? Always. Yes, true. Okay, so that's not too bad. But here's an existing record. Should I do a duplicate check? No, because this record with this date and Yves Beaupre is absolutely already in the database. I brought it out of the database. If I say, is it a duplicate, what's it going to say? Yep. Because it's not looking for a different record, it's looking for the... It's looking for the same record, right? It's going to look in the same, it's going to take the same date, the same name, and say, is that already in the database? Of course it is, I just brought it up. All I did is change the size. Ugh. If I do this, should I check for duplicates? Yeah, because I just changed the date, and how do I know that there wasn't already an Yves Beaupre, and actually there is, right? An Yves Beaupre on 213. So now I changed an existing record to match one that's... The trick here, so to speak, is to sense when the logical keys, there comes the darn word again, when the logical keys change. If the logical keys have changed, then do a duplicate check. If they haven't changed, because I just changed the size of the pizza, don't do a duplicate check because it's obviously out there. And so what we need is some technique, and we'll do this when we come back from break, we need some technique to sense that my logical keys have changed. And for those of you doing car maintenance, you got to check 3 fields. Did this one change? Or this one change? Or this one? Oh, wait a minute. How do we know if they change? Ugh. I'm going to give you a trick that is about as clean as I think I can make it to sense that one of these 2 fields has changed. One of her 3 fields have changed. Yours, Val, might be 3. I don't know. 4. Who knows what the logical keys are? You should from your design. But if you've got 3, 4 fields and you have to say if any one of them or more have changed, then do a duplicate record check. We got to find some way to make that relatively easy, and that's what I'm going to show you after the break.